Hey, DDTHJ here, and welcome to RLBot Start-To-Finish EP2. In this series, we'll be making a bot using Python to play Rocket League from scratch. In this episode, we'll be covering the pre-processing step and start laying out our bot's foundation. Hey guys, welcome back to the series. So today we're going to be focusing on the pre-process step and state calculation and controller calculation. We won't actually be programming in the switching of states and the choosing of controllers because that'll be for the next video where we really dive into some of the math. This is just going to be laying out some rough building blocks for us to start playing with. And just to get in the habit of doing cool stuff early on in the video, I'm going to go ahead and show you what the final product of today's episode will look like. I already have it up here. This is what Gosling currently does. It's currently programmed as an ATBA, so it'll just chase that ball around. But you can notice that unlike the current ATBA that you guys probably have in your Python example, has some interesting behavior. And it can go up walls. So yeah, what this guy is currently programmed to do is follow around the ball. He slows down when he gets close to it, but he will push it along and keep up with it. He can drive it up the wall, get some wall touches in there, and that's that. Now if I hit the ball pretty far away, I can also show you that he has dodging. And he's pretty good at it. So yeah, this will be the final product that we produced today. And I'll go ahead and show you what that looks like. You can minimize these. Alright, so here's what you probably have, or something very similar. This is the Python example code. You might have an extra method up here called initialize agent. Depends when you downloaded the framework. I don't have it, but it doesn't matter. And this is what we're going to be turning it into. So you'll notice we have a vector3 class, an object class, and an example APA class, which is a state. We've got some code here. The actual get output has been shortened. It's just make a controller state, pre-process the game, and then execute the current state. So that actually simplifies. And then we have an example controller, which is bloated mostly because of the dodging code, which we'll get into. We've got the pre-processing code, and we've got some utility functions. In the next episode, we'll also be working on organizing all of this. Right now, I'm just have it all in one file, which is okay just because it's not that big yet, but next episode, we'll definitely start putting these things in their own files. So the first thing we're going to do today is clean up the Python example file, or whatever you've renamed it to, because we're not going to be using most of this stuff. In fact, first thing you can do is just get rid of everything on the bottom of the file, the get car facing vector and the class vector2. Inside the get output, we can keep the controller state, but all the ball location stuff and steer correction and all this, that can go. We'll leave the controller state changes in here temporarily, but we do have to change this turn to a 0 because we don't have that variable anymore. It was one of the things we deleted. And this is probably about as simple as it gets. We'll go ahead and run this just to make sure it does run, and I'll show you some interesting things we can do with this. So let me just go in here. This should be all good. I'll click run. And you can see now that Gosling is just going in a straight line because we have him driving forward without steering. So we'll follow him as he flies off the ceiling. And now let me show you this. This is the window that opens when you're running everything, and you can see that it's got some stuff printed out in here, and we can actually use this as a console. I found some useful tricks. So I'm also going to bring up Gosling real quick, and let's just say we had something messed up in here. Maybe this was still turn. if I save this file, you'll notice that immediately we start getting some errors thrown up in here, and it's hard to read, but you can make it out that it says name error, name turn is not defined, and it'll tell you the line number. And I mean, this is just a regular Python console, so in real time you can find, oh, I messed up this variable, it needs to be a 0, and as soon as you save the file, it reloads, and you can keep playing in your current game without having to restart anything. And in fact, if I change this to a 1 or something like that, and I save it again, you'll see that info, it was reloaded. If I come over here, you can see that Gosling is now turning in a circle. So we can update our code in real time, and we can catch errors in real time. So if you're ever programming, it's good to be in a game, maybe just have it pause or something, and every time you make changes, you can save and watch for errors. Now we'll go look at how we're going to start implementing some of the changes I've talked about for preprocess. We'll start with preprocess. Now the preprocess step, I mean, we're turning GameTick packet into our own structures, so we have to create our own structures, and the main one that we're going to be using in this project, I've just called it OBJ for object, and all that is really just something to hold a bunch of vector 3s, and vector 3s are just going to be regular Python lists with 3 values in them. Alright, I'm just going to jump right in and start programming some of this out, and I'll explain it once I have some of this typed out. So this will be the vector3 class. In the init, the only thing the vector3 holds is a list, which we're going to call data for now. And that'll be that. And I think we're just going to leave that alone right now, because that might be all we need to get away with the first things we're going to do. The next thing we have to do is create the object, which is going to contain a bunch of vector 3s, so I'll go ahead and do that. Now, the object is going to contain, we're going to use it for our cars, the ball, sometimes we'll be using it for target locations, that kind of stuff. So a lot of information has to go into these. We have to store the location of the object, the velocity of the object, the rotation of the object, the rotational velocity of the object. For the ball, we want to store something called its local location, which I'll get into, especially in the math episode. And optionally, well, for now, optionally, the local velocity. And I don't know, maybe for cars, we'll also store boost. So a lot of stuff goes into here. And I already have this code set up, so I'm just going to do copy paste. But so you guys can copy paste. I'll be uploading this online, and you'll be able to download this file. Now it is nice if you go in and create these classes yourself, just so you know what you're working with. But if you want to take the shortcuts and add this stuff in, then that's fine too. Actually, I'm getting rid of the boost there, and I don't need the spherical location. Can get rid of that. So what's going on here? All those parameters that I said earlier, I mean, that's what all these are, and they're all going to be vector 3s. And when we initialize the object, we're just going to have zeros in there for now. So this will just be a bunch of zeros, and that's all we need for our object file. Now that we have our structures, we can actually make our preprocessing step and get everything from the GameTick packet into our structures. So you can see here in get output, we're receiving a packet, which is a GameTick packet and simple controller state, yada yada. I'm actually going to change packet to game, just because I prefer game over packet. So once get output is called, we'll make our controller state, and then we're going to do self.preprocess. I had that right the first time. And we'll pass it game. So now I have to go make the actual method. Self.preprocess method will take, well, the agent and the game, and you'll start to see why the preprocess step is necessary. let's say we wanted the location of our car. In order to get the location of our car, we need to go through the documentation. And in fact, I can bring that up real quick. Here's input and output currently, and this is what the GameTick packet looks like. Here's a sample at least. So inside the GameTick packet, we have something called game cars, and then we have physics, and then we have location, and then we have X, Y, and Z. So in order to actually get the location of our car, it would be game.gamecars, and then you have, since this is a list here, you'd have to set the index for the car you want. So game.gamecars index.physics.location.x. And then the whole other thing again for a .y. And then the whole other thing again for the .z. So the purpose of the pre-processing is just to make it a lot easier to get the information we need to get. So let's get started on that. We're going to have an obj for our car that we'll call me. And in fact, I guess the first thing we should do is create the initialization step. So when we actually initialize Gosling, what we'll do is we'll create some of these objects. So in Gosling, if you don't have it already, you can go ahead and add this. So once you have this, this is slightly different than what you might be used to. Normally we have the double underscore in it. The reason is because base agent has its own init method that has to do some setup before we can run any code. So it does its stuff and then it calls this. So we'll use this one. It's for safety really. And inside of here we'll make a self.me, and that'll just be an object. And we'll go ahead and create one for the ball, and we'll call it ball. So inside of preprocess, we can go ahead and start getting the GameTick packet into these objects. Now, self.me.location.data might not look much better than game.gamephysics, car, but all that stuff. But I'll show you that it actually does simplify out. Self.index, for those wondering, is where our car is in the list. When our agent is initialized, one of the things the framework passes to us is the index of our car in the game cars list. We just don't see it here because it's in the base agent code, not our code. So as you can see, we've already got, this is just to get the X value. So pretty crazy, but we have to do this 2 more times to get the Y and the Z. So if you ever wanted to just get the location of stuff by itself, it's an insane amount of typing, which is why we're doing this step in the first place. So you can see that even though this is quite a bit of a handful to type, it's definitely saving us on having to type this whole mess. That's what the pre-processing step is for. Now I'm going to go ahead and add the other things because there's also velocity, rotation, and rotational velocity. One interesting thing about the rotation data, this is what is known as a rotator. So it includes pitch, yaw, and roll instead of X, Y, and Z. And this is in the input and output. We can see it right here in rotation, pitch, yaw, and roll. But everything else is in X, Y, Z. So this one is the only one that's different. And the only thing that we had to change here was make this dot pitch, dot yaw, and dot roll. So here's all the data for our car. Now, again, this might still look like it's quite a bit of data, but remember, this is just filling up the vector 3. Once the vector 3 is filled up with this data, then we can just use it as a vector 3 instead of a dot location dot data. It'll just be dot location. So anywhere else in the code, if we needed the location of our car, we can type self.me.location, and that'll be this vector 3. So it cuts down this much typing into this much. Next step for preprocessing is to get everything for the ball, which is the same deal. Again, I'll make sure this code is online because I don't want you to have to type out all of this. It's all just repetitive, copy, paste, change, little things. So don't want to have to do that. Just want to get to the fun stuff. Now that we've gotten most of the repetitive stuff out of the way in preprocess, there's just a few smaller items we have to get out of the way in the end. One of is the local coordinates of the ball. And I'm not going to go into detail on what local coordinates are just yet. That'll be in the next episode where I cover the math. But for now, you can think of it as what the car sees when it's in the fixed hard camera mode. It's probably a good analogy. And the bulk of our math that we use in this episode is really just going to be converting the ball coordinate, the regular coordinates, into local coordinates. So you can see right here I have a method called to_local, and that just takes the ball and the player and it converts the ball coordinates into local coordinates. Now I already have these methods pre-made. So first off, I'll go ahead and grab the to_local, and again, this will be covered in the next video. And one other thing we need is to create a matrix, it's not really a matrix, but we're going to call it that. And the matrix is generated from our rotator. So this rotation.data, since it uses pitch, yaw, and roll, is technically a rotator. And we need to convert that into our matrix that we use for the local coordinates. So there's another function I've got here, rotator to matrix, and it takes our object. So one last quick thing we have to add in here is self.me.matrix equals rotator to matrix. And we pass it our car. And then one other thing we need for this episode, as we need things, we'll just be adding them to preprocess. One thing we need is our boost. So we'll go ahead and add that. So now this should be almost all set up. Now, the next stuff we get into will be creating the beginnings of our state system. But while we have all this here together, we're just going to go ahead and double check that it can run without crashing. So in here, we're already calling self.preprocess, so all of this stuff should happen. So we'll go into the game, and since the file is saved, this will be up here, and you can see, there's an invalid syntax, which is probably probably caused from me pressing the record button. Yeah, it's up here. Delete that, save, and now let's see. So we've got unsupported operating types for vector and vector3. And what this is referring to, let's see, line 52. Yeah, right here. So in order for to_local to work, there's a couple things we need to do in our matrix. One of which is I need to be able to subtract, or not our matrix, my bad, our vector 3s. So one of the things we need to be able to do with our vector 3s is subtract a vector 3 from a vector 3. And we also need to be able to do the dot product with our matrix, which is actually just another vector 3. So in order to do that, we actually have to add these methods to our vector 3 class. So down here, I'm going to go ahead and add these in. So what this allows us to do is subtract two vector 3s from each other and multiply. So now that this is saved, you should be able to go back in here, and you can see it loaded and it's not throwing errors everywhere. And I'll go ahead and just for fun, click run. Our car is still spinning in a circle, which is a good sign because I believe from the last time we checked, that's what we programmed it to do, is spin in a circle. Now one thing we could do, just again as a test, we could do self.me dot we'll go ahead and we'll see if this prints. So if I mean, now that we've got this printing in here and it's loaded in, you can see our console is being flooded with coordinate values, and this is where the car is as it spins around in circles. So we now have an easy way to kind of see what values are in game and make estimations and whatnot based on those. So to finish off this episode, we're going to go ahead and add a very rudimentary state and a very rudimentary controller, and just make sure that we can get those working together to return an output. Our code's quite a bit larger than we started with. So the first step is to be programming the state. Now, of course, there's going to be plenty of states, and each one's going to have its own class, but they're going to be pretty similar. We're not going to do inheritance just because these states are different enough that they can be their own classes. One thing that all states will have in common is that they will all have a variable called self.expired, and by default it will be false. And remember from the first video, once the state expires, this will turn true, and then we'll have some logic that'll discard the state and get a new one. Okay, so I've got the state set up, and it's really simple. Again, this is just an example, and this state or this behavior is just an @bus, so we're only going to drive towards the ball. Now remember from the previous video, all the state really does is it chooses a target location and a target speed. So in this case, our target location is just going to be the ball, and the target speed is going to be how fast the ball is moving plus just how far we are from the ball. That way, the farther we are away, the faster we go to catch up. Now, you might be wondering why this is agent.ball instead of self and whatnot. Well, this is just because the class is outside of Gosling, and for all purposes, Gosling is an agent. Agent and bot are kind of synonymous. I prefer to call it an agent. So all we're doing here is everything that Gosling has, all the pre-processed data and whatnot, we're giving that to the state so it can do its thing, and then what it does in return is it calls a controller that we put inside the agent. So we don't have that controller set up yet, so I'm going to go ahead and start programming that. I haven't quite finished example controller, but I just want to stop and show you what I've been doing. You can see, just like I've explained in the last episode, we're receiving a target location and a target speed. And what we're doing, well, first off, we're getting the local location into its own variable. So the target location.local location, this will actually be, target location will actually be an object. And so the object will have a local location associated with it, and I'm just renaming it to location for simplicity, because the controller is going to do all of its math in local location. So that's why I have it like this. Now the controller state, simple controller state, this is just grabbing a simple controller state so that it's easy to, once this example controller returns, it'll immediately use its output to drive the bot. And then ankle to ball, we're just calculating, do we have to turn left, do we have to turn right to get to the ball? And again, we're using the local location data in order to do that. So anyways, I'll keep going now. I'm going to do a little bit of copy pasting here. This block of code here just says if our angle of the ball is greater than 0, we're going to turn right. If it's less than, well, greater than 0.1, we'll turn right. If it's less than 0.1, we'll turn left. Otherwise, we'll just go straight. We're going to refine this later on, but this is really just a quick and dirty, let's get the bot going. The next chunk of code here, in fact, actually, let me just separate these. This will be for steering. This will be for throttle. So of course, if the target speed, if the ball is rolling faster than what we're currently going, then our throttle will be set to 1. if it's above 1400, which is the that's where you enter supersonic, and we're not airborne. I'll explain this part later. This is when we're dodging. So we've got to make sure we're not dodging. We got to make sure that the target is going faster than supersonic and that our current speed isn't already at the max car speed. Then we can start boosting. Now, of course, if our target speed is less than our current speed, then our throttle will be set to 0. So the last chunk of code that I have here is for dodging. So we have this variable called time difference, and I need to go ahead and set up self.start. I'll go ahead and do this up here and initialize. And since we're using the time module, I got to go import that. Yeah, so this dodging, this time difference, is just a measure of how long it's been since we last dodged. Because, of course, we can't try to start dodging again if we're still in midair from the previous one. So if it's been 2.2 seconds, and we're farther than 1,000 Unreal units from the object, and we're kind of pointing towards the ball, that's when we can start dodging. So it'll set our timer to our time difference to 0, and all of this code only runs if the timer is like between 0 and 2. So all this is doing is saying like, oh, okay, if the time difference is less than 0.1, so like as if we had just started a jump, then it will jump and it'll start pitching down. And then from 0.1 to 0.15, we'll stop jumping because we have to let go of the button before we can press it again. And we'll keep pitching down. And then anything above 0.15 but less than 1, we're going to keep jumping, or we're going to start jumping again. We're going to yaw towards towards the ball, and then our pitch is going to keep going down. So that'll get us to go all the way through the flip. And then that's it for our example controller. This just returns a controller state. Now there are a couple things in here that we do have to touch up. Maybe wondering where I got the distance 2D and velocity 2D. It's around here somewhere. Yeah, velocity 2D. Those are more functions that we have to implement. And they're going to be simple. It's just getting the distance between two objects and the velocity between two objects. So I'm going to go ahead and add that now. Alright, now that I've got these functions in here, let me just explain how they work real quick. The velocity 2D is just Pythagorean theorem. So we're adding the x component of our motion and our y component of our motion together. Well, the square of the components, and then we're taking the square root of that, and that gets us our overall two-dimensional velocity. So our velocity in the xy plane. It doesn't consider whether or not we're falling or not. It's just, XY movement. And distance 2D works in a similar way. However, there's just a little bit of different stuff going on here. Distance 2D takes a target object, two target objects. However, you can optionally just take a vector 3. So you could pass either an object in an object or a vector 3 and a vector 3. So this is instance target object vector 3. Figures out if we're using vector 3s or not. If it is a vector 3, then it'll just do the difference between the two vector 3s. Otherwise, it will use the dot location and dot location of the objects. And then this is just distance formula, square root of their distances the square of their differences added together. So that's pretty simple. Now let's go ahead and try to run this, because I'm sure there's some errors that we can pick out. Instead of returning a controller state now, we're just going to return, what we'll do is we'll make a variable here called self.state, and this will be the current behavior that we're executing. And we'll set it to example ABBA. You can see it's already, it's because I have 8 over here. Okay, so we'll be returning self dot state dot execute. Save that, and let's go see what's going on here. Oh, state.execute takes a couple variables. Duh. So what we can do here, this just takes the agent, so all we have to do is type self. Oh. I was missing the parentheses around the example atpa. You see, without them, it's saying we're missing an argument. And funnily enough, if we pass self, comma, self, this reloads and it's actually valid code. But that aside, example appa with parentheses, and hop back into our match. And this is our bot. So that's it for this video. We covered the pre-processing step and laid out the tools we'll need to complete our state system. In the next episode, we'll be covering the math and organizing our project. We'll also write our first real state for shot taking. Thanks for watching. I'll see you in the next one.